Hi everyone, this is an example problem predicting a redox reaction. Here's the scenario. Predict the reaction when an aluminum bar is immersed into a cadmium nitrate solution. What we're going to do here is follow the 5-step method. The first step is to make a list of every substance that's present. Here we have an aluminum bar. An aluminum bar, that's aluminum, solid. I don't have to go and double check. The word bar lets me know that we have solid. We have it gets immersed in a cadmium nitrate solution. This is an ionic solution. An ionic solution means that the chemical dissociates, so I'm going to put the respective ions into my list. We have cadmium ions, that's Cd, 2+ aqueous, and aqueous nitrate ions. Because it is aqueous, because it is a solution, we also have water present. Liquid water goes into our list. Okay. The first step of the 5-step method is to make a list of every substance that's present in the question. I have solid aluminum, cadmium ions, nitrate ions, and liquid water. The second step is to go through and label all possible oxidizing and reducing agents. I need to find aluminum solid here on the table. It's right here. It's on the right-hand side of the table. Aluminum solid is a reducing agent. Cadmium 2+ ions are here on the left-hand side. They're an oxidizing agent. Nitrate ions, if I search and search and search and search, there is a spot where there's nitrate ions, but it's nitrate ions in combination with hydrogen ions. We don't have hydrogen ions here in the question. So nitrate ions alone are neither an oxidizing or a reducing agent. They're nothing on their own. Water is both. It's an oxidizing agent and a reducing agent. I can find it on the left-hand side of the table right here as an oxidizing agent, and up here on the right-hand side as a reducing agent. It's both. The first step is to make a list. The second step is to label all of the possible oxidizing and reducing agents. The third step is to find the strongest oxidizing agent. Out of the two, which one is stronger? It's the one that's highest up on the table. So water is here. The cadmium ions are higher up. Out of the two possibilities, the cadmium is the stronger oxidizing agent. It's the strongest oxidizing agent that's present. What we're going to do is copy its half reaction right off that table. I copied exactly this half reaction off of the table. Out of the two reducing agents, which one is the stronger one? The one that's lowest down on the table. Liquid water is way up here as a reducing agent. Aluminum way down there. It's the stronger reducing agent because it's lower down on the table. So the SRA, strongest reducing agent, is the solid aluminum. Here, instead of copying the reaction exactly as it appears in the data booklet, I'm going to reverse it. I have solid aluminum, so the half reaction that I'm writing down has to start with solid aluminum. So I am reversing it and copying it down, or, if you prefer, we're going to copy it down from right to left. The first step is make a list. The second step is label all of the possible oxidizing and reducing agents. The third step is find the strongest oxidizing agent and copy down the half reaction from the data booklet. find the strongest reducing agent, and reverse the half reaction from the data booklet and copy it. The fourth step is balance the electrons. Here we can see that there's 2 electrons being gained, but the aluminum is losing 3 electrons. That doesn't balance. What we'll do is multiply the half reactions so that the electrons balance. It looks like this. This half reaction for the cadmium, I'm going to have to multiply it by 3. That would make 3 cadmium ions, 6 electrons, and 3 cadmium solids. With the aluminum down here, I'm going to multiply that half reaction by 2. So we would have 2 aluminums, 2 aluminum ions, and 6 electrons. We can see that this is going to be 6 electrons gained, and down here 6 electrons lost. We've balanced the electrons. And we need to take these 2 half reactions and combine them. We say add the half reactions together to come up with the net ionic equation. We have 3 cadmium 2 plus aqueous ions and 2 solid aluminum to make 3 cadmium solid and 2 aluminum ions. There's no canceling here aside from the electrons. They're the same thing on opposite sides of the arrow. They all cancel off. And we were left with a balanced net ionic equation. It's important we're not quite finished yet, but before we do, we can talk about this reaction. It's balanced in 2 different ways. The chemicals themselves work out to be balanced. 3 cadmiums on either side, 2 aluminums on either side. However, we also have the charge on the left and right hand side also being balanced. Here there's 3 ions that are 2 plus each. That's 6 plus. This one's neutral. So the total charge of the left hand side is 6 plus. When we look at the right hand side, this one's neutral. And here we have 2 3 plus ions, 6 plus. If we've done these early steps correctly, the net ionic equation that we have will have the chemicals balanced and a charge equality. Our final step is to indicate whether this is a spontaneous reaction or not. The aluminum solid is here on the table, and the cadmium ions are up here. We have the oxidizing agent higher than the reducing agent, and that's a spontaneous reaction. So our final step is to indicate the spontaneity. When we're asked to predict redox reactions, we're going to follow the 5-step method. Make a list, label all of the oxidizing and reducing agents, find the strongest oxidizing agent and copy its half reaction from the data booklet, find the strongest reducing agent, reverse the half reaction from the data booklet and copy it down, balance the electrons, combine, add the 2 half reactions together, and finally indicate the spontaneity. And I hope that helps.